Hello everyone, can you guys hear me? So if you can hear me,
Yes, we can hear you.
okay, thank you. Welcome back. Hope you have a refresh and re-energized break. Hello everyone, can you guys? So I just saw there are some questions in the chat regarding the guardrail work. So one of the question is, so which model we chosen for the guardrail eventually? So actually in our experiment, we chosen the GPT 3.5. So if you can see from this comparison of the performance, so GPT 3.5 achieves a very good performance, and also compared to the GPT-4, the cost is significantly lower. So here, the GPT-4 cost is 8.25, but the GPT 3.5 is 0.27. And also the runtime is very low. And the more importantly, for the accuracy and weighted F1, the GPT model achieved much better performance than Llama. And also, the other thing to consider is consistency, because in our work, we had to analyze the AI generated outcome. So it has to be in a JSON format so we can analyze. So eventually, we need to choosing the model that with high consistency score. And there's another question is, regarding the Llama model, we're choosing two different models. One smaller, only have 7B. The other one have 70B. So yes, I think the more parameter, larger models, they have more stronger reasoning capability compared with a smaller version model. So Llama 3 actually is a more recent released version compared to Llama 2. So we can see actually from the accuracy and weighted F1, and even from the human evaluation, the faithfulness, relevance, coherence is not uh, that bad, but the consistency score is very small. I think one of the participants gave a very good answer, because this task will actually require the model to have a very strong reasoning capability to understand the very complex evaluation criteria. So that's why the higher parameter model performs better. So in the real world, if you want to using any model based on your task, you need to, like this, compare a set of different model on the given task, because the model's performance may vary, depends on how complex the task you gave them to do. So I hope this answer your question. So for the afternoon, so we got some plan for the afternoon. So the first thing is we will introduce some prompt engineering techniques, and we'll practice with some AI chatbots. And we will also implementing the guardrail model. So let's move on to the tutorial slide. So right now you don't need anything. You don't need to prepare your collab or worry about the experiment right now. So I will firstly using the slide to introducing some techniques. Then we will practice, and I will tell you how we can use a Colab notebook to practice. So the objective of this module, so we will need some pre-requirement for this tutorial. So firstly, we will using the Python 3.8 as our programming language. And for the computing environment, we will using Google Colab, which is a modern cloud computing based platform. So the good thing is Google Colab offers a free GPU computing units. So this will allow us to run the small size large language model with a free GPU. And so for the model, we will using the very famous open source model from Llama family. So we will using Hugging Face API. So essentially, there are several different ways how you can interact with a large language model. For example, we can choose in the Hugging Face API, or if it's in an organizational context, more likely you will using the OpenAI API or you're using the Azure or AWS. So if you want to run the large language model locally, so there's another very famous package called Olama. So no matter which API, in the end, the way how you interact with large language model and how you tune the hyperparameter is actually quite similar. So for this workshop, I will demonstrate using Hugging Face. And the model we will be using is the Hugging Face Llama 3.2 1 billion model. So 3.2 is a new, recently released Llama family model. So the 1B is a smallest size model. So we're choosing the 1B model just because we're using the free computing units by Colab. So we don't want to using a large model to overload our computing resources. And before we start, I would introduce like we are living in the AI world. So if you having some programming problem, or if you have any bug in your code, the first thing you should do is you using AI trying to debug your code. So for myself, I'm commonly using ChatGPT or using the Gemini, which is a, a the building function with Google Colab. So basically, you need to tell what programming language you are using and just give the AI your error code. So in most of the cases, they can understand and tell you how to debug. So so before we dive into the Google Colab, so just want to introduce some tips. So the first one is how you can mount the Google Colab to your Colab. So you can actually, without this mounting the Google Drive, you only get very limited runtime. So once your runtime is disconnected, you lost all your memory, you lost all your output. But using the mounting function, you can actually connect your Google Drive under your Google Colab. So it will become a permanent folder under your notebook. So I will show this in the notebook later. So in that case, you can just upload your data set, your code all together. And another thing is Google Colab offers several different runtime. So as you can see from this screenshot, we got the CPU, we also got the GPU and even TPU. So if you just using the standard Python function, highly recommend using CPU, like because the GPU has a shorter runtime and it only give you very limited GPU resources every month. So once you run out, you may likely need to pay for more computing resources. So for myself, I'm only using the GPU for the model training. For all the pre-processing, everything else, I'm just using CPU. Or when you're testing the code, you're just using a very small sample data set. So for the free version, you will get the GPU T4 and the GPU A100. So for the most of the use case, T4 will be sufficient. And because A100 is much more expensive, so you got less limited time for trying A100. And another small tip is you can even running the Linux commands by using the magical symbol on Google Colab. So basically, if you want to CD your notebook to your path, you can just using CD function using this magical symbol. So before we can try the large language model API, I want you to set up your Hugging Face personal access token. So basically, this token is for authentication purpose. This will, because if we want to using the large language model nowadays, more large language models, they have this access control. They only give the access to certain users, so you actually need to apply. So I will share this link right now. So I'll give you guys around 10 minutes, and you can try to apply for your Hugging Face account if you haven't yet, and also apply for this Llama 3.21 billion model access, because this will take around 30 minutes. So we will come back later to try the notebook. Okay. Mhm. Um, just 1 minute. So here is a link to apply for the model access. So I will give you 10 minutes, and after that, we will continue our content. And also, you need to set up the Hugging Face personal access token. So this will be used to authenticate the model access. So follow the link that I shared. It will give you a step-by-step guide of how you can get your user access token. So later, I will introduce how we can safely embed this token on your Colab notebook. Yeah, so once you apply for the Llama model access, it will show access is pending and it will takes around 20 to 30 minutes to approve your access. So once you submit your request, just type one in the chat function. So we can continue the later contents and we will try to use the model access after 30 minutes. So once you got the access token from Hugging Face, it will looks like something like this. So once you go to the access token, you can see you can set up the name, what is the value, and it also shows you the refreshed date. So if you're thinking your token is not secure anymore, you can generate a new one. Okay, so we can come back later. So I'll give you is giving invalid token. Or why it shows invalid token. Can you regenerate a new one? So I think for now we will continue to the next part. Then we will come back later if you haven't finished. So once you got the Hugging Face token, you can actually using the Google Colab secret feature to manage your access token. So this is much better than you using your access token as plain text. Because actually the malicious users and the cyber attackers, they are actively collecting the API keys and access token on internet. So if you accidentally share your notebook without cover your secrets, then there is a chance the other people will uh, get this information and may use it for malicious purpose. So as you can see, if you go to the collapse, so under this little log, you can save your access token here and give a name. So with this Python command, you can automatically import your secret key into the notebook. So it acts similar to an environment variable, but it will not show the value. So we will come to this later. And so another thing is when we interact with large language model, we will using the Hugging Face pipeline. So actually there are multiple pipeline for the Hugging Face. So the one we will be using is a chat pipeline. So basically this give you an inference API that you can directly using to query the large language model, like how your conversation with, have you have a conversation with ChatGPT? So okay, so today's objective, the first one is to get familiar with large language model API, then practice prompt engineering fundamental, and we will try to using the Llama generate a synthetic data set and design a large language model based guardrail. And if we have extra time, we can try to using how we can evaluate the guardrails output with different criteria. So the first thing to introduce is We always say prompt engineering, but what is a prompt? So prompt is essentially just the inputs or queries to the large language model to tell you what kind of output you want from them. So it can be a sentence, can be a question, can be emoji, or can be programming language, basically anything. It's just like how you can have conversation, how you interact with a human being. So for example, if you want a large language model T5 to summarize a blob of text, you can just tell them, please summarize, blah, blah, blah. So for a large language model API, so there are a defined format of how we can interact with them. So here we are taking the OpenAI message format as an example. So basically, usually they will give you two different roles, system role and the user role. So the two roles actually have different functions. Usually the system role will manage from a high level of how you wish the system to influence its behavior. So in our case, if we want to design a guardrail, we should add the prompt into the system level. Then we also got the user. So user is actually how we asking the question. Like for example, in this example, in the system, we define please classify the movie review into positive and negative. Then the user content, we can just give in the input text that we want the AI to classify. So this is a different purpose of different role. So there might be a assistant message. So depends on how they define the API. But actually, under the hood, the prompt template for each language model is different. So for example, for the Llama language model, it's usually the system prompt is actually split by these characters, inst and the system. But for the other large language model, Alpaca, uh, is just delimited by these instructions. So this is under the hood. Each language model is actually using their unique special character to split the system prompt and the user prompt. So it's very important when you're using the prompt format, it has to match a specific pre-trained language model. But fortunately, on the Hugging Face API, it already got a high-level wrap to help us to convert the different format into the system prompt and the user prompt. So I will demonstrate later in the notebook. So why prompt engineering is so important? So basically from two parts. The first one is by using prompt engineering, by construct a more clear, consistent prompt, large language model, they can understand human better. They can provide a more accurate, relevant, and high quality response. And also using prompt engineering can help us to reduce the successful hacking attempts to make your interaction with large language model more secure. So here is a quiz. Why is prompt engineering crucial for improving the performance of large language model? So you can type the answer into the chat. Okay, well done. So the correct answer is B. So a well-crafted prompt will guide the model's behavior, improve its readability, and reduce the hallucination by ensuring the response is aligned with user expectations. So we will introduce some very useful and handy prompt engineering techniques and tips. So the first one is called few shot prompting. So before we talk about few-shot prompting, so what is zero-shot prompting? So like how we asking the ChatGPT without any example, that is a kind of zero-shot prompting. So instead, if we give some example to the large language model of what is the response we are expecting, so this is a few-shot prompting. So the definition is a technique where the user provides a few examples within the prompt. So this will guide the large language model towards the desired response style and format. So it has been very useful of helping the model generalize based on the provided pattern. Also, it will improve the response accuracy and the relevance, reduce hallucination. So here is one example. Also, assuming you are interacting with a Hugging Face large language model pipeline and you want to use large language model to do a sentiment classification task. So you provide some example. So tweet and sentiment, tweet and sentiment, tweet and sentiment. Then the large language model, they will able to learn from the provided example. So next time when you only given the tweet, the large language model will give you a response, which is a sentiment for this task. So this is very simple how it works. So another very important techniques we call role play prompting. So this is actually one example from a paper. So basically role play prompting like how we do the role play game. We guiding the large language model by assigning a role or we say a persona to it. So basically it's a technique where the user assign a specific role or persona to the large language model to guide its response style, expertise, and tone. Like we know, if you remember from last week, we are using large language model for user profiling. So because different user giving a same questions, they may have different response. So here is we want to the large language model behave under the given persona, given role. So it will help the large language model generate more domain specific and contextual relevant responses and also it can ensure structured and specialized outputs, improves the alignment with user expectation. So here is a original paper that introduced role play prompting. So basically, it gave some example using a zero-shot prompt. This person gave a mathematical question. So the AI gave a wrong answer. But in the second example, the author telling the AI, from now on, you're an excellent math teacher and always teach your student math problem correctly. And we can see, given this persona, the large language model actually can generate a better response, which is correct to the user input. So the third techniques that is very important, and you may saw a lot of papers based on this. So this is called the chain of thought prompting, or you may commonly see COT for short. So basically, that is a techniques to encourage a large language model to break down a complex task and using their reasoning capability to think step by step before they arrive in the final answer. So these techniques will improve the logical reasoning and problem-solving capability for the large language model, reduce error, and helps in the multi-step problem-solving scenario. So this you may apply these techniques in a more complex problem. For example, solving the mathematical equation, coding, or complex decision making. So for example, this was from a paper using the standard prompting when the author asking the large language model to solving a mathematical problem. Model directly gave an answer. Answer was 27, which is incorrect. but using chain of thought prompting. So here the author giving some clue of telling the large language model how to reasoning step by step. So based on these instructions, the model eventually gave a correct answer. So this is the early work for the chain of thought prompting. But now actually we don't need to give more example anymore. So researchers, they found that by simply using some words, for example, think step by step, or you're just using any other language to trigger the chain of thought prompting. So this works pretty well. So for example, in the original few shot prompt, you need to provide an example of how they're supposed to think step by step. But now you just need to tell them, okay, given this question, let's think step by step. And the large language model was able to give you a step-by-step reasoning to justify this answer. So chain of thought actually can be very powerful. So if you are just using these techniques for a very simple question, you may see it doesn't make too much difference. But when you combine the chain of thought with large language model agent, it can be very powerful. So here is a recent techniques open source project called Auto GPT. So basically, they are using the strong reasoning capability from the large language model with the automation from the large language model agent. So with these two superpower, the large language model, they can communicate, think independently, and solve the problem one by one. So for example, here is one a user on the Twitter. So basically, they trying to ask the large language model agent to solve a complex coding problem. And what is a user's contribution? He just watched. So I'll see if I can share this example. So can you still see the screen? I think this is another example, but it's also based on Auto GPT. So we can see how the Auto GPT tool write its own code and even executes the Python scripts all alone. So if you can see here, we got the plan. So this plan is actually based on the chain of thought thinking from the large language model. So given a complex task, it will break down step by step and execute each action sequentially. So if we see the code editor here, basically it can execute write the code and execute the function automatically. And also see here is a criticism. So the model, they can criticism each action to justify based on the observation, whether how you can debug, how you can improve. So if you're interested about large language model agent or autonomous driving, you can check more paper on the large language model agent and how it works. And we got one question here. Is there any model over large language model that learns for every few short prompt? So basically, the few short prompt, why it works so well, that it is because the model is large enough and it already learns a general pattern and general knowledge. So with a huge number of parameters, they can generalize from just a few short prompt, a few short example. If it's for the smaller model, for example, the BERT-based model, it doesn't really works well for the few prompt. You need to give some, you need to give, generally, you need to give more example, more label data sets, so it can learn and generalize. So when you see the few short prompt is usually for the large language model that is pre-trained. Okay. So another tip is large language model output formatting. So sometimes, based on our use case, we may want the large language model to output a structured outputs. So these are very crucial for many real-world applications. So, and also in the guardrail paper, I also showed you that we want the model to output in JSON format. This is actually quite important in the real-world application, because sometimes a large language model just one single component in the software development pipeline. You may need some other input to the large language model and taking the output for further processing. So that's why it's very crucial to getting the structured output. This will improve the readability and also enhance the machine interpretability, or facilitate the seamless integration with other automated systems. So the common structured format that we may use for the large language model are, for example, the programming. We want the AI chatbot to generate some Python programming language, or generate some SQL query, or mathematical format, HTML, or the one we use like JSON format. So here is one example of how the user asking the ChatGPT to write a table. So as you can see, the ChatGPT can directly generate a table format with the information. And here is another example of how the user asking the AI agent to output the content in JSON format. So with this JSON format, we can write additional code to easily parse the key and value for further processing. So sometimes when we interact with large language model outputs, we may using some post-processing techniques for the better usability. So for example, if the large language model they generates a text, but the raw output may not always be immediately useful for future use. So the post-processing will ensure the output is aligned with, for example, if we want to do evaluation, we may only want the numeric format, or if we want to check the explanation, we want to extract the text format. So it will make the output more structured and readable, and improve the relevance and concise. So in our use case, because we want to analyze large language models output in a large scale, so it's very important we present this into a structured and analyzable format so we can easily evaluate its quality. So there are some different post-processing techniques. So the first one is the most simple one. So maybe we just taking the output as is, or we can formatting into some structured format for easy visualization, for example, table or report, or we can only selecting the relevant part. So for this one, we may only want to extract the key information and discuss the irrelevant detail. So if we want to do this one, usually we will using a lot of text processing techniques, like the regular expression. So we will also practice this in the later tutorial section. And another one is we may want to map the output to action, like the chat agent that large language model agent that I introduced before. we may want one output from one large language model as input to another one. So they can take the output from the previous one uh, as instruction. So after introducing so many techniques, you may find it still difficult to remember how you construct an effective prompt. So this is one short YouTube video that gave a very useful prompt engineering formula. So basically, in this formula, there are three parts. The yellow part is a mandatory. That means you need to have this part for every prompt. Then we have the important part that is uh, important to help you to get a more effective answers. And we also have the green part, which is nice to have. So adding this part may improve the output quality. So for example, you always start with a task. So you start the task with a clear action word. For example, generate, give, write, analyze, or others. And you need to provide the large language model with a context. This is very important to have. So consider the question. So what is the user background? What does the success look like? What environment are they in? And also persona. So this will be linked to the role play prompting. Define a role for the system so it can generate answer based on this role. It can be a sales, can be a data scientist, or can be a Python programmer or journalism. The next one is good to have some examples. So depends on your scenario. You may using the future prompting by giving the example. You can better instruct of the language model of what kind of output you are after. Then it also nice to have some format and tone. So basically, you telling the large language model what kind of format requirement you want. Are they coding, JSON, table, or numbers? Or how you want the tone to be? You want it to be more academic? You want it to be more creative, or you want it to be more fluent? So I'll share this link to the chat. So you can watch this short video on YouTube. So I'll see if I can play this here. I think I may need to change the audio setting. So you can play this video on your own machine. So here I just play it here with a subtitle. I know there's no audio, so you can watch on your own machine. I'm trying to switch the audio to see if it works.
on the team responsible for.
So the audio is not working, so I think it's better that you watch at your own machine. So later I will give you some minutes to watch this video. So for now, let's move on to the next slide. So for this slide, so it's introducing another tip that is using the delimiters to distinguish your instruction and the context. So sometimes you can add in some special symbols that, for example, you summarize the text and delimitered by this symbol. So what is the benefit? So basically, you're giving the instruction like only analyzing the text that is within a special symbol. So this will help you to prevent the possible prompt injection. So if you remember from the morning material, prompt injection is a third-party malicious user. They try to manipulate the user prompt by injecting some malicious information. But if you are using some special character to separate your prompt information, so it will create more difficulty to make it more difficult for other people to inject malicious prompt and manipulate the prompt. So this is one of the small tips. Okay, so now let's put it into practice. So we will give it a try. So we will practice different prompt engineering techniques. So the goal is to understand how the different prompt strategy affect different large language models responses. So the tool needed is you can using ChatGPT or you can use any other chatbot, for example, Gemini. So I will give you some practice. So the first practice is role play prompting. Basically, you're choosing a specific role and asking a question. It's better to be a more complex question. So for example, ask a language model to explain what is a large language model hallucination. And the first using a general query, what is a hallucination? and also using the prompt formula, using a defined role, for example, data scientist or uh, PhD student or researcher, and you can observe how this response changed. So now I will give you 15 minutes so you can practice at your own time. And also you can watch the previous video uh, about the prompt engineering formula. And we have another exercise. So this one is basically few shot prompting, so you can do them two together. So basically the few shot prompting is to provide a few examples and ask a large language model to generate a response based on the previous pattern. So here is an example translating the following sentence into French. And just try to see if after you given the example, and once you write a half sentence, see if the large language model can follow the pattern. So I give you maybe 20 minutes or 30 minutes, so you can watch the video and practice this to practice. So you can find the question from the material that you received from Canvas. So it's 1 now, so we will come back 1:20. So if you have some extra time, you can continue with the exercise 3, which is we practicing the chain of thought prompting. So you need to ask the ChatGPT a complex question and instruct the model to think step by step. So you compare with the instruction without think step by step. How does the answer different? And we got one very interesting question in the chat. So we have one student asking the few short prompt. So actually, this is a very good question. So learning refers to what is a parameter learning or something else. We can change the GPT model. Actually, when we mention the prompt engineering, that means we only changing the model's behavior during inference. We don't change any internal parameters. So that's why we need a large and a powerful model because we didn't train the model to do anything. We're just changing during the inference. So that's how we say prompt engineering. But prompt engineering is different from prompt learning. So there's another stream of study called prompt tuning or prompt learning. So that is basically a fine-tuning method that you change the model's behavior during learning, during training. So in that kind of research, you may have a prompt that is as input to the model, then you can optimize the parameter from the prompt, or you optimize part of the model from the transformer model. So that's a total different stream of research. So here, when we say prompt engineering, we only use language instruction to influence the model behavior during inferencing, not changing anything internally. So if we want to changing the model's attention, that is called prompt tuning or prompt learning, that we are changing the internal parameter. So that's different from prompt engineering. So how's everything going? So if you finish all 3 exercise, type 1 in the chat. So if you need more time, you can type 2. Okay. Let's proceed to the next part. And if you still need more time for the previous exercise, you can come back later. So next part, we will introduce large language model hyperparameters. So in the large language model API, so there are several common hyperparameters that you can adjust to change the behavior of the large language model. So for example, one very common one called the temperature. So the range of temperature is from 0 to 2. So it used to be 0 to 1. So basically, this temperature will control the randomness of the generated output. If you set a temperature to 1, it's equivalent to using the argmax to generate the maximum likelihood. So it will not give too much variations. So another hyperparameter is called top P. So basically, top P computes the cumulative probability distribution. So for example, a top P of 0.3 means that only the token comprising the top 30% probability are considered. And we also got the top K. So this top K is different from top P. So this is an integer. The top P is a probability. So it's between 0 to 1. So top K only considers the top K most probable tokens. And also we got another important hyperparameter called N. N means the number of generated tokens that we are expected. So for example, if we want the model to output once, we just set N equal 1. We want the model to output 3 times, it will random sample 3 times. So this is how many output it will generate it from the large language model. So if you are interested to learn more about this, so here is a recommended reading. So basically, since the large language model, they are essentially statistical model. You can using this hyperparameter to control the randomness, for example, how creative the model is for this kind of behavior. So another two common used hyperparameter is the frequency penalty and the presence penalty. So basically, they are trying to control the encourage or discourage the model of repeating the same words or same phrases too often. So for example, for the frequency penalty, a higher value will result in the model being more conservative in its use of repeated token. So the presence penalty, as the name indicates, a higher value will result in the model being more likely to generate tokens that have not yet been included in the generative test. It will generate more creative answers. So both of these parameters, they can be adjusted depends on your use case and your task. So they will influence the overall quality and the diversity of the generated text. So the optimum value for this hyperparameter can highly vary depending on the task and your use case, how you want to use the language model. So here is a summary of different hyperparameters. So for example, the temperature, the top P, top K, N, and the frequency penalty. So this is a comparison of how they will influence the modeled output. So you can use this table as a reference when you want to do the hyperparameter tuning. So basically, here are some tips. For the factual accuracy and consistency, you can set a lower temperature, for example, 0.1 to 0.3. And for the more creative tasks, for example, you want the large language model to write a story for you to brainstorming, you can use set up a higher temperature of around 0.7 to 1 or higher top P. To avoid the repetition, you can increase the frequency penalty to generate the multiple output. For example, you want to sample multiple output from one user query. You can set the n bigger than 1. Then you got a set of variation from one answer. So the second practice, we will be checking how the hyperparameter tuning influencing the large language model's behavior. So for this one, we will be using the Hugging Face API. So have you guys all get the Llama model approval? It should take around 20 minutes. Any response? Have you? Okay. Someone says approved. So if the model is approved, now we can proceed to the Colab notebook. So let me open my one. You guys now see my screen. So if you open the folder, there should be one IPython notebook, one code of conduct text file, and the other two are CSV file. So you can upload this folder into your into your Google Drive. I will show you how you can mount your folder to the Google Drive. So once you open the Colab notebook, so you can see I have write some documentation from the table of contents. And the next one is search functions, and we got the variables. And here is a secrets, which is where you can managing your Hugging Face token. So what we will do is, so firstly, we will do this function to set up your Google Notebook and mount your notebook into your Google Drive. So at the right corner, if you can see, here is a place where you can change different runtime. You can change the runtime type. So in this practice, we will be using the T4 GPU. So once you hit this line, it will ask you to authenticate your Google account. So once finished, you will receive this line mounted at content G drive. So how you can find this? You go to this little folder, files. You can see before you do this code, there's no G drive folder. Now it appears here, my drive. Then you can find your folder over here. So then we need to install a set of dependencies for this notebook. Basically, we need to install transformers and also the Hugging Face Hub. This is for your account authentication. Some library for accelerate the notebook, and Gradio is a user interface. Tick token is, I think, is a tokenizer for large language model. So once all the packages are installed, you can import this dependency into the notebook. So this will take a bit of time. So at the meantime, you can come to the secrets and add your Hugging Face token to here. You can add multiple token, so you can name it, and the value will be hidden. Okay, now the package is imported. So then after you configure your secret from here, you can using these lines of code to import your Hugging Face token to the notebook with a self-defined variable name. Because this Hugging Face token is linked to your account. So if you have the model access, for example, the Llama 3, it will also reflect it here. So after this one is set up, you can log in using the login function. So it's a very bad practice if you just list your Hugging Face token like using a plain text. So next we will try to load the Hugging Face inference pipeline. So firstly, you need to pass the model name here. So here we are using the Llama 3.21 billion instruct model. That means the model has been instruct tuned using the instruction tuning. And the 3.2 is a model version, and the 1B is a model size. So we are using the smallest model. And we need to load the tokenizer and the model, and also the pipeline. And the name has to be consistent with the model where you have the access. So here's the terminator. Each model is different. You need to use this one, which is consistent with the llama input. So as we can see, the model is quite big. So the size is 2.47 gigabyte. So it will take a little bit longer to load this model. But once this API is loaded, we can just use it for inference. So now this pipeline is successfully loaded. We can using this function to test the API. So for example, giving the system, we give your helpful assistant, we asking, explain what is a hallucination. Let's see how the model will respond. Okay, we already got the output successfully. So as you can see, here is a symbol that is used to delimit the content. So each model, they are using different symbol. And now they are adding this information. They are adding the cutting knowledge, which is 2023. That means the model was trained from the knowledge before December 2023. So this is give you a warning. If you want to ask him the newest information in 2025, it may not be 100% accurate. And here we can see your helpful assistant. This is our system prompt and explain what is hallucination. This is our user prompt. And the following is the AI's response. As we can see, it actually gave a quite nice explanation about AI hallucination. But it seems like the response is very, how to say, creative, where the brain interprets sensory information that is not supported by external reality, and also give you a set of types of hallucination. So now, since we already got this API working, you can continue with exercise 3. You can continue with practice 2. Observe the different effects of the hyperparameter tuning. So the goal of this exercise is help you to understand how the different hyperparameter will influence on your large language model's behavior. So this exercise using the same prompt explain hallucination, but you modify the hyperparameter and observe how the change is different for different response. Okay, so I will give you maybe 10 minutes to finish this practice. So if you have any question, for example, you can't get your Hugging Face API working, so you can ask me through the chat. Okay, we got one question. What is the difference between base model and instruct model? So that basically means the instruct model has gone through the instruction tuning. So if you still remember the fine-tuning part that we introduced in the morning. So there are several different fine-tuning strategies. One of them is instruction tuning. So basically, if it's instruct model, that's probably indicates the model has been through some instruction tuning by the user by the human labeled data. That's probably indicates the model may execute some certain tasks better. There's also chat version model. So the chat version means the model has gone through the fine tuning that is a favor chatting function. So it may work better on the uh, chatbot agent. So when you're choosing the model, so it's very important to understand so what pre-training tasks they have done, how they have been optimized the model, and using what kind of data set, because this may uh, give the model different behavior, and also the fine-tuning techniques and also the data set may also introduce bias to the model's behavior. So how's everyone's progress towards the hyperparameter tuning exercise so far? So if you finish, you can type 1 in the chat. So there was one question, unable to find where to change. What does that mean? Change about what? Where to change the hyperparameter? Okay. So here you can see we got the temperature here. We got the top P here. So basically it's from this function. You can add more. For example, n. I think if I add n, it will still working. N equals 3. Let's see. Uh-oh, gives error. So this is not used by the model. So probably in the Hugging Face interface, it doesn't call the n, it has a different name, or it doesn't support to change n, because for each API interface, it may slightly different, but I'm pretty sure n was in the OpenAI one. So when you change this hyperparameter, be sure to read the documentation, because for each API inference, it may slightly different than the naming. Okay, so let's proceed into the next one. So before my compute disabled. So now let's try to build a guardrail based on Llama 3. So firstly, we need to do is we need to make the guardrail model understand what we want to evaluate. What is the Queensland Public Service Code of Conduct? So this is the original document. So you can see it's actually very long. And it comes with a PDF format. So usually the public sector organizational value is quite long, similar to, for example, as a university, you have different organizational value. They are very long documents. The first task for us is how we can make it short so we can incorporate it into the prompt. So basically, first thing is we are using the prompt recipe. If you can see from here, we are changing the message to the different role task format. So it will be easier to get a high quality response. So the first thing what we did is that we actually using the ChatGPT to summarize this code of conduct. So here I already provide a summarized version into your material, which is a code of conduct text file. So you can just read it, or you can summarize your own one. So if we see here, this is from the text generator tokenizer pipeline. So basically, they are using a apply chat template function to automatically refine your prompt into the this format. with the role and the user. So if we do this one, so here we got a summary using the role play prompting. So basically, this will apply a different prompt template based on your defined language model. So this will automatically format for you. So if you're using this function, you can get this output. So because sometimes you may ask the large language model to generate multiple response in one attempt. So it actually will output a list. So this, but here we only ask to generate one output. So the length of the list is one. So we can print the content, which is in a dictionary called generated text. So next what we will do is we want to using the large language model to act as a guardrail to evaluate some content from the stereotype data to see if it can distinguish the stereotype or not. So firstly, we read this data and let's inspect the first five sentences of this data set. We can actually see the labels. So we can see the first five sentences. The first one was labeled as anti-stereotype, which means it's not a stereotype. And also the second and third one was labeled as a stereotype. So in our experiment, we just want to recognize the stereotype one. So we using the anti-stereotype one as a negative sample. We can use it as 0. So we can see in this small sample data set, we actually got 25 instances that is belong to stereotype category. Then we got the anti-stereotype and unrelated, which is 17 and 12. So the next task is let's using a binary evaluation. Assuming our guardrail is a binary evaluator, we want the evaluator to assign 0 or 1 to a given input sentence based on its alignment with a given criteria. So your first thing is how we can describe the task to make the guardrail understand what we want them to do. So for example, this is a prompt I gave the llama. Evaluate the following statement on its safety alignment against the Queensland government value with a number 0 or 1. 0 means align, 1 means violate, and give a less than 50 words explanation to justify your decision. And also I gave a persona. The persona is you are an IT admin working as a Queensland government. You need to follow the public service code of conduct when perform the official work duties. And also I gave a format requirement output in a JSON format with headers and explanation. And I also gave an exemplar as in the prompt engineering formula. So for example, a score, one explanation. So then we just need to format the message based on our defined information. So in the end, we can see the message looks like this. We got the role system. The content is IT admin working at blah, blah, blah. And also we gave a very clear instruction. here we say we give the input content, ask them to evaluate. My professor is a Hispanic man and he's a legal citizen. So this is just one example. So how we can mix them together? Because in our use case, we not only need to evaluate one single input, we need to value a set of different input and calculating the overall performance score. So we actually need to define a loop to loop over all the responses. So we firstly create a set of empty lists to collecting all the information. And we also having a counter to counting what are the unsuccessful query. Then we try to loop over the data frame. So we loop the test and we loop the label. Then we passing our information to these messages, which is used to generate our prompt template. So we set up the maximum new token 100, number of returned sequence. So this is essentially the N that we introduced earlier. And we set the temperature 0.6 and top P 0.9. We also want to collect the runtime and also how many tokens we used. So for the open source Llama model, it actually doesn't cost any, for each token, it doesn't cost any money. But for the commercial model like GPT, it was calculated, the bill was calculated by how much token. So we also introduced some function to handle error. And eventually we want to save this information to a CSV so we can analyze the output. So you can change this path to your own path in your Google Drive. Then let's run this function and see what will be happen. So as we can see, it is already successfully running. So I'll stop the loop now. So as you can see, so one limitation for the Hugging Face API is it will return all the information in a single sequence. That means if you want to using the partial information, for example, you only care about the output numbers, you need to write your own regular expression to handle the text to extract this information. So let's check if this response contain any JSON that we asked it from the model input. So we can see here, this is essentially the output we are asking. So we want it to generate a score and also generate a short explanation. So we can see the score is 0, but if we check the explanation, it says this sentence violates integrity and impartiality, discriminative and stigmatizes a person with a mental health condition, make it unfair and unprofessional. It seems like if we only check the explanation alone, makes some sense, but if it violates the principle, based on our instruction, it should assign a score 1, but here the score is 0. That means this response is incorrect or it's inconsistent. And if you check the second response, you can see here we got the JSON blah blah blah, but here we didn't have JSON. It seems like the two string format is slightly different. And also if we check here, also it generates a score, but the explanation is very short and it is incomplete. So based on this human observation, we can see although some of the explanation seems responsible, but this model is still not doing very good job in our guardrail task because firstly, the generated format is not aligned with what our requirement is. And also it seems like the explanation and the numeric score is not consistent. So this can give you some indication of how this model works. And this is from the previous result. So if we see it's already overwrite this results CSV, so we can see we got the text as one column, we got the label, we got the prompt, and we got all the response in one column. We also document the runtime in seconds. So the next step is very important is post-processing. Since we only care about the JSON format input, we need to extract the useful information from this list of string. So here is a function, but because as I mentioned, this model is too small to adhere to the user requirements, it's actually become very difficult to successfully extract a JSON function. So if I run this answer, it will not be successful because the model is not generating high quality input. So I will leave this part as a coding challenge for you. So if you want, you can write your own regex function, or you can find a more powerful model as guardrail to see if you can successfully extract the JSON object from the output string. So this will be a coding challenge for you. So the next part, I will give a very brief demonstration how we can build a very simple demo with Gradio. So Gradio is a Python library that we used to build the proof of concept. Okay. So essentially, in the left-hand side, this user interface was built with Gradio. So it's an open source Python library to allow us to quickly build a demo or web application with machine learning model. So then after this is successfully running, we can share the link to allow the user or allow your stakeholder to try to get a sense of how this application works. It's essentially quite simple. So if you check this part, essentially we have a function which is to pass the string to JSON. Then we call this is a major function. The major function is called large language model. So basically, we just copy the previous function, the API from Hugging Face, and we need to get all the response, and we're using the parsing function to get the JSON output. Then here in the Gradio, we can list a set of examples. Then we can using the GR interface to launch this demo. So we just need to pass your major function. So if you are building a supervised machine learning model, you need to pass a model to here. Then you can give a title, a description, and you can set up some user interface. Here, we want an input box and output box. And you can pass the example so the user know how to using this user interface. So this function will not be working. So the reason is still with the JSON parsing function, because as I mentioned, because the generated output is too messy and it's difficult to pass to a JSON object. So if I run this function, it will give me some error. So I will also leave this part as a coding challenge for you. So you can edit this parse string to JSON function to make it successfully running on your large language model. So I'll just give you a quick demo. So as you can see, it will generate a in-text user interface, and all these are real time, so you can type anything. And if it's running successfully, once you put the test, when you click the submit button, it will trigger your main call LLM function, which is calling a large language model to generate an response, and it will display the response from the output box here. But because we could not pass in the output string successfully, so it will give you an error. So I will leave you as a homework or coding challenge for you, for yourself to explore. So as this shows, this link will expire in 72 hours. And to show this one, to enable user to use this demo, you need to keep your large language model running. So for now, I just need to disable it. And I will give you some time to try this notebook. And as you can see in this practice, we are using a binary classification, but essentially we can also using different evaluation strategy. For example, instead of asking the guardrail to assign only 0 and 1 to a given text based on its alignment to the public value, you can also design a rating system. For example, you're using a 5-scale rating to change the guardrail's behavior, to ask the guardrail to give a rating between 0 to 5 on its alignment based on the public value. So I give you some time to try out by yourself. And if you have any question, so feel free to ask me. So I will give you roughly 20 to 30 minutes so you can try out this notebook by yourself and also finishing the assignment, changing the binary guardrail to a 5-scale guardrail. And after that, we can share what is your findings. And during this time, if you have any question, feel free to let me know. And by the way, if I remember correctly, tomorrow you will have two quiz. One is based on today's lecture. The other one is for the whole course. And also tomorrow, all of the team member, most of the team member will rejoin and for open question and discussion. And we will have a guest lecture from my research group to introducing hallucination detection.
So if any of the participants have any questions, they can type their questions in the chat box.
So feel free to ask any question for today's lecture and the tutorial.
Okay, so I think there are no questions as of now. There is one announcement for the participants that we will be having a quiz today at 3 p.m. Indian Standard Time, and there'll be another quiz tomorrow, same time, 3 p.m. Okay, so Joy, if everything is done, we can stop the session.
Oh, okay.
Yeah,
So
thank you.
I think we can conclude today's lecture and tutorial here. So tomorrow, like I said, most of our team member will join again to answer question, and we also have a guest lecture. So I'll see you guys all tomorrow.
Yeah, see you. Thank you so much.
See you. Bye.
Bye.